It is September 28th. And so I'm going to talk about IDA Pro tonight. And next week I'll talk about the assembler CTF, not a chapter from the book. And I may talk about some of the extra credit projects with types of Windows security defenses too. I think that's probably what I'll do. I'll just demonstrate a few of these. I won't have a normal lecture. And then we'll go on with recognizing C code constructs and assembly after that. So let's talk about IDA Pro, which, remember, I skipped it earlier because I said this is usually where students get pretty upset about it being kind of hard. But I think if you've already used Ollie debug a bit, this will not be so troublesome because you've seen assembly code, which is what usually freaks people out. So IDA is the interactive disassembler. It is the professional product used by all the experts that reverse engineer things. It costs thousands of dollars to get the full-featured professional version, but there are a couple of free versions, older versions you can use, and one of them is the one we're using here, freeware version 5. So the freeware version only lets you disassemble 32-bit x86 code. It doesn't let you do ARM or x64 or anything like that. It does have some ability to detect common library code, which is nice. And so when you load a program, it'll typically come up in graph mode where it shows blocks of assembly code with these arrows where you're here, and if there's two arrows, then it's ending in some kind of if statement. And if it's true, it goes one way, and if it's false, it goes the other way, and so on. And then you can hit the space bar and get back to text mode where you just see the old line printer output type of thing where you see the lines of assembly code. One thing about IDA is, notice that the address, this is in the text section at this address 401.040, and these are all at the same address, which doesn't make any sense. What happens is the real assembly code is down here, and this is 40, 41, 43, so that's the real code. What it does is it adds some comments automatically generated above there, and it just puts the same address on all of them, and these do not represent any actual code at all. These are just comments. I don't know why they don't just put stars here or something, but anyway, that's how it looks. So it adds comments here. It assigns a name to it. This is the main entry point. It makes up some names for variables and tells you how big they are. It tries to help you a little bit. With file systems, you can delete a file, but the process still has it open. Yes, absolutely. That's right. No, I think that's exactly what the deal is. You can delete a file, but the process in memory keeps going. That's not enormously surprising. Yeah. All right, so there's the default graph mode display, where all you see is the comments up here, and then the commands down here, and you don't see any addresses at all. So this is not incredibly helpful. Like it says call sub 40. I don't know why they think this is so great where you have no addresses at all. That's why I always change it like this, like they say in your book. I turn it on to have line prefixes in options, and then opcode bytes. Turn that up to something. And now you see the address and the raw hexadecimal bytes, and then the instruction. And I think this is much more useful. Because, of course, if I find something interesting, I'm likely to just go into HXD and modify the code, and I would want to see this right here. And I certainly want to see this address, so when I see it jump somewhere, I can find out where the address is and know where it's going. All right, so here's the arrows. A red arrow is a conditional jump, not taken. Green is conditional jump taken. And blue is an unconditional jump. And if you have a loop, it'll have an arrow going up to repeat an old command. So those are all pretty obvious. And so here's a jump not zero. So if it's not zero, it will go here. And if it is zero, then this jump will not be taken, and the red arrow takes you to just what's the next spot. And you can tell because this is from 50 to 52. This is when it doesn't jump, it just flows through. This is when it jumps down to 56. And that's the reason why I like to see these addresses. Makes it easier to understand what's happening. All right, so you can hover over an item, and when you do, it will highlight all the other places nearby where that item is, which is just handy. So if you want to know what EBP is used for, you can see all the other EBPs around here, and that will help guide you through. And here's text mode. You see the address, you see what section you're in, .text, and here's those arrows. The arrow jump, this is a jump that might jump down here. Here's some kind of jump that might go back up. The dashed are conditional, and up is loop. So there's a conditional here, jump 0. Anyway, and here's these automatically generated comments. Like here it's pushing a value onto the stack, and that value points to a string, and it shows you what the string is here, exactly the way Ollie did. If you remember Ollie would do the same thing. if you refer to an address and the address is the start of a string, it will put some of the string there so you can tell what's going on. All right. You've been there. All right. So it has a lot of windows, which I found very confusing at first, although you get used to it. It has a lot more windows than OllyDebug. Functions show every function, its name, what segment it's in, its address and length, and then some more information, which I forget what this stuff is. L for library functions, and I don't remember what these other flags are about. There's a name window. Every address with a name, like main is part of where it will start. Start is also part of where it will start. Here's other names and addresses. So that's functions and named data and strings, that sort of thing. You also have strings, which I think this is probably referenced text strings, as Ollie calls it. I don't think it's just sequences of bytes that are readable, which is what I'm used to being strings. I don't really know which one of those things it is, but you see them here. And it has these addresses. So the fact that it's only showing you the ones in the R data makes me think that these are referenced text strings. These are strings that are used in commands. They're not just, otherwise they'd be ones in the text section where a couple of bytes just happen to be readable. So I think these are used strings. And that's why they are sensible strings that actually look like they're intentional, not just random spam. Your imports and exports we talked about a lot. Imports are functions that are used, so they're going to be like Windows API calls like this, get string type, and so on. And the exports, for a normal exe, they'll just be one export. That's something like start or main, and there's no other. There's only one way to come in from the operating system because it's not a library offering many functions. It's just an executable, and you're only supposed to come in at one point. If it was a library, you'd see a whole bunch of exports. And then you got structures, which show you the data structures. If you hover over one, you'll see. So you have, these are data structures where you have some object that includes many pieces of data. Like this includes the old ESP, then a pointer, then previous ER, a handler, and so on. These are common, and we'll see more of them when we get to Ghidra, which maybe we'll do next week. We'll see. Might do Ghidra. Anyway, then there's cross-references. If you double-click on any function in the functions window, it will jump to the code and other views. You can pretty much double-click anything in one view to get to where it's referenced elsewhere. So function calls in assembly code work like this. If I'm going to call string length, I will push values onto the stack and then call it. So here I push a value on the stack and call it. This size is only, I think, one value. I think these other things up here are just the prologue preparing a stack frame. This is where you push a pointer to a string and then you call a string length function. And it will just return the value, how long is that string. Returns usually coming in the EAX register. All right, if you get lost in IDA Pro, which is easy to do, you can do Windows Reset Desktop to get you back to the normal desktop. It's a good thing. There's also forward and back buttons like a web browser, which help. So here's some navigating. You can double-click any entry in any window like strings. And if you double-click a string here that says like heap allocate, it will take you to this string where heap allocate is stored in the text section. So you see, it takes you from this string to that location. You can double-click any address in disassembly to go there. So if I'm calling something and I want to know what this does, I could double-click this and it'll jump back and show me that code. So you navigate through your code sort of like clicking links in a web page. And like I said before, you have forward and back buttons and history here, so you can decide you don't like where you are and go back a few steps to pick up from where you used to be. This is really useful. I didn't know what this was for a while. The navigation band is a horizontal linear map of the code. And the most important thing is the dark blue. The dark blue is the user-written code, which is almost always what you look at. What you want to look at. The rest of it is things like constants, library code, and stuff like that. And this takes some time to populate. When you open a file, it will process it for perhaps several minutes, and you'll see these colors changing. And it's not really ready until these colors stop changing. So if you get lost, you can just click blue to get back into the blue code. You can drag an indicator around in here to move through the king quickly. You can also press G, the same way you do in Ollie, to go to any address if you know the address or something you want to go to. And you have a lot of searches. You can search for next code, next data, text, and many, many other options. All right, and there's cross-references. So if you look at a cross-reference here, code xref. So here I am at the start of main, and there is a cross-reference that points somewhere else. So if you hover over this, a yellow box will appear showing you the code that's referenced. So this shows you that this thing called main is called from somebody else. And this is the cross-reference, and here you see the thing that calls it. So you can take a quick look to see what else refers to this, and then you can decide whether you want to go examine that or whether that's not interesting and you want to go do something else. What if the exe is packed? Would that affect the horizontal map? Well, I haven't tried it on a packed exe, but I think what would happen is the map would still be true, but what you would see is the unpacker. You wouldn't see the unpacked code. And this is one thing about IDA. IDA does not have much debugger functions. In principle, there's a little bit of debugger in there, but you can't run the code in IDA. So if you had a packed exe, I think you'd be pretty much hosed. You'd only see the unpacker, and the actual exe would be sort of compressed in one of these data sections. You'd have to first go manually unpack it with Ollie or something, and then look at the unpacked thing, if you wanted to get much good out of it. That's a very good question. That's why, in my experience, debuggers are much easier to use and really much more powerful. And I only use disassemblers when you have to. Because disassembler is static analysis. You're reading the code, figuring it out. You're not able to run it and let it demonstrate what it does, which is a lot easier. All right. Now here's the thing. IDA Pro will name a function. So here it found a function and it names it sub 401040. It also tries to name the local variables, give them things like arg0, arg4, and that's of course pretty useless, but you can change those names and it will remember them and propagate them. So people spend like a week just running IDA with multiple high-resolution monitors to analyze something, and they're gradually figuring out what every module is and everything and naming it and propagating it and deducing it. So really the cross-references here are very important, and you save them. And this is what Axiom X took these courses. The guy that developed the new jailbreak for the iOS, and he paid $5,000 to get a proprietary version of IDA Pro, and spent months disassembling the iPhone software until he found a new 0-day. Well, it wasn't exactly 0-day. What he did was reverse engineer a patch that Apple had put out, but he found the checkmate exploit. It was the new jailbreak, the only new jailbreak in 7 years. So it was pretty awesome, and he did it in IDA. So that's what all the pros do. They seriously dig into software, and they become an expert at this. And there could be like 2 or 3 whole courses in IDA. I'm very much just a beginner in IDA. I only know a few simple things. The pros get deeply into it the way professional graphic artists get deeply into Photoshop. And they make their whole living professionally working in this tool. All right. Whereas, compared to that, Ollie Debug is just sort of a kid's toy to cheat at games. It's useful for analyzing malware, but it's not anything like as powerful as IDA if you get really good at IDA. You can graph things various ways. Haven't got much good out of these things, but you can these buttons here let you graph something out. Flowchart and function calls seem to be over. Xrefs too just let you see a graph of all the cross references that go to a certain function. Well, I tried this. I opened calc.exe, the Windows calculator, and I found check Windows genuine status in calc. I think this was in the days of Vista or so. And I said they actually wanted you to they would verify your product key before letting you use the calculator, which was kind of funny. So I tried to find out what references were there. And this is what the map is. From startup, it goes to main, and that goes to Windows genuine. So apparently it did have the capability to check your Windows genuine status when first starting up and deny you access to Calc if it wasn't genuine, but as far as I could tell, that feature was not in fact used. Is IDA prefer to edit values and then patch them to a new executable? Not that I know of. It may be possible, but I've certainly never done that. It's a very good question. But as far as I know, it does not have that capability. You would just have to do it in a hex editor. But I think it has plugins, and the Prey version has more features and all that. It might be in there. And it even does have some ability to run code like a debugger. I just hear everybody say it's not really worth it. It's not a very good debugger. So, all right. You've also got xref from that show all the paths that exit from it. So here's where the genuine status goes to various functions from there. So you can get some kind of graphical layout that might help you deduce what a function is doing. And there's other kinds of graph options here that I haven't used much, but there's a variety of them. And then you can enhance it. By the way, there's no undo. But you can rename things. Like I said, if you can find a name of a function, you can give it a real name, change it in one place, and IDA will update it every place else. So you'll be quickly recording your findings and annotating the file. But of course, if you're making mistakes, you're going to be just messing it up and making it harder to understand. So here you have, you can rename arguments. So here's raw code where you just have the names of like registers and stuff. Here you'd say argument for the variable, that's the port as a string. So I rename that. Then somewhere it turns it to a port. That's variable 598, so that's a port, and so on. So as you name things, descriptive names, they'll automatically propagate. And what you're doing is basically decompiling. You're taking the raw assembly code and moving it closer to readable source code, like in C and such. That's the idea. You can add a comment. And you can add a comment that will echo to all the cross-references either way. And it shows you everything in hexadecimal, but if you want to, you can right-click it and see it in other ways like octal or binary. This is apparently base 10, but you can make it hex, octal, or binary. And you can use named constants. IDA has a library of a bunch of constants. So if you're using, say, Microsoft API calls, there are a lot of constants that have certain values for Windows XP Software Development Kit. So you could choose a symbol and then change immediate values to these symbols to make it easier to read. So you'd have something like this. Here you're going to call something like DW share mode, which is a Microsoft API call to share something. And instead of just having meaningless values here, you can say this is file attribute normal, open existing, null, that sort of thing. So you'll give it the expected meaningful names that match the documentation for the Windows kernel and the Windows API. And you can extend it. You can have IDC or Python scripts, and there's a bunch of them available to download things and extend your IDA. So in principle, you could do pretty much anything. So that's a quick run through. Let's take a look at some Cahoots, which are here. This might be everybody. Apparently so. All right. So which feature shows instructions in boxes connected by arrows? That's called graph mode. All right, which one shows user-written code as dark blue lines? Yep, that's the navigation band. Good. All right, what kind of code cannot be disassembled by the free version? Yep, you can't do 64-bit code. All right, how do you switch from graph mode to text mode? That's it, the space bar. All right, how do you move to a specific hexadecimal address? Yep, G, which is the same, I think, in Ollie debug. All right. All right. I know who that is. I know who that is. And I know who that is. Good. All right. So, leave that one, and let's see, it's only 30. I can keep going. I'm just going to make a